let's do some more homework help. Question B is this function. You might wonder, where does this come from? This is actually modeling the arrival rate of cars or traffic on a freeway throughout the day. So it's got a wavelength of 24 hours. And it's shifted a little bit, and it's got a center line of 6,000, and it's got a amplitude of 4,000. It's a cosine, but it's a negative cosine, so it starts low, kind of near midnight, maybe off by 3 hours, then reaches a peak during the middle of the day-ish, off by 3 hours, and then comes back low toward the end of the day, off by 3 hours. We had done a version of this in a previous homework where we didn't know U substitution yet, so we didn't have a complicated thing here, we just had a t. But now here we've got the full version of it. I'm going to actually just do the whole thing here in this homework video. So you should be able to, if you're stuck on this problem, you should be able to try to anticipate from one step to the next. And then once you've seen the whole thing, you should be able to just go and do it all again without watching the video again. So that's my study recommendation to you. There's actually two good ways to do this problem. One is to break it up into two parts and do the two parts separately, and the other one is to not break it into two parts. So let's try breaking it into two parts. So we'll do the integral of 6,000 dt minus the integral of 4,000 cosine 2 pi t minus 3 over 24 dt. Oh, one thing I should mention quickly. Can I collapse the 6,000 and the 4,000 into just 2,000? Let's do this. Let's think of a simpler case. Consider something like 3 plus 5x. You'd say that's a line with slope 5, right? If that was a tangent line formula like f of x plus f prime times x minus 0 or something. So that's a line with slope 5. Is that equal to 8x? Well, that's a line with slope 8 that goes through the origin. Those are not the same thing. So that's one way of seeing that we can't just collapse the 6,000 and the 4,000 into just 2,000. That changes the amplitude, that changes the center line, we don't want to do it. Once we've broken this into two parts, this part, fairly straightforward, right? So we can just say the integral of 6,000 is 6,000t, and we're done. We could do a plus c, but we'll leave that for the very end. Then what do we want to do for this? I'd say u equals what? Just that inside stuff, 2 pi t minus 3 over 24, which you could also write as 2 pi over 24 t minus 3. That kind of makes it more obvious what the frequency term is and the shift term separately. And then what's du? Well, constant multiplier rule on the 2 pi over 24. What's the derivative of t minus 3? It's 1 minus 0 dt. Or you could just say it's 24 over 2 pi, 2 pi over 24 dt. Should you change the 2 pi over 24 to 1 pi over 12? I would say no. Anytime I see 12, I think months of the year. Anytime I see 24, I think hours of the day. Anytime I see 2 pi, I think full circle or full cycle. So this is telling me it takes 24 hours to do a full cycle, where if I saw it as pi over 12, I would be thinking half a cycle in 12 months of the year. I don't know. So as much as you love simplifying from your other math classes, here I would just leave things as they are because they mean something. All right, so we've got du equals 2 pi over 24 dt. So we could divide both sides by 2 pi over 24. So we could write it as 1 over 2 pi over 24 du equals dt. Or we could just actually invert that and say 24 over 2 pi du equals dt. All right, so now we're ready for our u substitution. the 4,000, you could leave it in, you could move it out, either way is fine. So 4,000 cosine u, and then dt gets replaced with 24 over 2 pi du. So we still have the 6,000 t here, and now we're ready to take the antiderivative. So we got 4,000. Antiderivative of cosine is positive sine 24 over 2 pi. I already took the antiderivative, so I don't write the du anymore. And then substitute back. Do you notice this is a little weird? It's got t in this part of the expression and u in that part of the expression. I think it's not technically wrong because we already wrote on the paper what you could do with u to relate it to t, but it's possibly slightly confusing, but at least it's not inside an integral anymore. So we got 6,000 t there, minus 4,000 sine of 2 pi over 24 t minus 3 times 24 over 2 pi. And we're done with all the integrating. I guess we could have put that there too. Can I cancel the 2 pi over 24 and the 24 over 2 pi? Nope, you can't bring that factor inside. So just leave it like that. So at this point, you would you could take the derivative to check, or you could graph the integrand, graph our integral answer here, then graph f prime. That's a good way to do it. I mean, big F prime. So that was the breaking it into two parts method. If you're not breaking into two parts, I like the idea of not breaking it into two parts because then we get one formula all at once that's the antiderivative. Here we kind of got our antiderivative in bits and pieces. But this does end up kind of nastier, but I still want to show it anyway. So let me copy the problem again. 6,000 minus 4,000 cosine 2 pi t minus 3 over 24 dt. We'll use the same u and dt as du dt as before. So we'll have integral of 6,000 minus 4,000 cosine u 24 over 2 pi du. And then what? Well, we can take the integral of this. So integral of 6,000 blah 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 du is 6,000 u. Integral of 4,000 cosine u is 4,000 sine u. All that in parentheses, copy the 24 over 2 pi. And now substitute back. And we get 6,000, and instead of u, I have 2 pi t minus 3 over 24 minus 4,000 sine of 2 pi over 24 t minus 3. All of that times 24 over 2 pi. And you can see the 2 pi over 24 here is going to cancel the 2 pi over 24 there, but it would still be on this term. So I get 6,000 t minus 3 minus 4,000. We can bring that on over here. Sine of 2 pi over 24 t minus 3. Okay, so we got our antiderivative. Is it the same as what we got up here? Well, the second term is the same, but the first term looks different. How is it we got different answers when we did it one way versus the other? Well, what if I split out the 6,000 minus times negative 3? I get a constant, right? And that constant is actually a different, we have a different plus c here than a plus c there. I can adjust the plus c by 6,000 times negative 3, and then I get the same answer. So these together give it a vertical offset of 6,000 times negative 3, which is absorbed in the plus c the first way we did it. All right, there's actually one more way to do it, and that's using what I call the big four rules. So remember, one of the big four rules was the integral of cosine ax plus b dx is 1 over a sine of ax plus b plus c. All right, so what do we have here? We have 6,000 minus 4,000 cosine 2 pi over 24 t minus 3 dt. So how can I apply this to this? Well, ax plus b is a linear function. 2 pi over 24 t minus 3 is a linear function. So all I need to do is identify what the a is. So a is whatever is multiplying my variable of integration. So that's just 2 pi over 24. I could identify the b. The b isn't just 3 here, it's 2 pi over 24 times negative 3, but the b ends up not making any difference in the multiplier out front. And what this is saying is just whatever linear function you have, just copy it. So I don't even have to identify the b, I'm just going to be copying that. So I can say integral of 6,000 is 6,000 t. Constant vertical multiplier rule on the 4,000. Integral of cosine is sine of linear stuff, so I just copy the linear stuff. And then I've got that factor of 1 over a. So 6,000 t minus 4,000 sine of all that same stuff. And then what's 1 over 2 pi over 24? It's 24 over 2 pi. So that's how the big four rules, at least this one of the big four, make life a lot easier on problems like this, because you can avoid the u substitution altogether. It's kind of already done for you right here. And it's a good general thing to think about. I mean, in some sense, it's a shortcut, right? But it's also a conceptually useful shortcut to say integral of a cosine wave is a sine wave at the same frequency and offset, and just with the amplitude adjusted this particular way. That's a nice general thing that we kind of now see using u substitution, but we don't even have to think of it as a u substitution.